Hey everyone, my name is Nick Raboy, and I'm a developer advocate at Couchbase. I work out of California and I focus primarily on SDKs and developing with Couchbase. So this is where we're going to go today. We're actually going to see how to develop an application with Go that leverages Couchbase NoSQL. So before we jump into actually using Couchbase with Go, we need to take a step back and take a look at developing a web application with Go, because there's many different ways that you can do this, and I want to make sure that we're all on the same page. So when it comes to developing a web application, you can use the standard HTTP package that comes with Go, or you can use a more feature-rich multiplexer. So some of the popular multiplexers that exist are the Gorilla Mux, HTTP router, Bone. There's a few others, and there's no, I can't make the judgment call on when it comes to picking which is best. It's basically whatever meets your needs the best. And the benefit of using a multiplexer is you'll have easier access to route parameters, query parameters, and you'll have easier access when it comes to manipulating bodies of requests. So we will be using the Gorilla Mux for this example, but definitely feel free to use your own. There is no requirement when it comes to a multiplexer and using Couchbase. You don't even have to build a web application if you don't want to. So just as a refresher to brush up on what the Mux is and how to use it. So essentially what you'll do is you'll create a set of routes. So if you look in the main function here, I have one route, it's for products, and there's a key, which is actually a route parameter. When a GET request is made over HTTP to this route, the product handler function is called. So inside of the product handler function, we can do mux var to get any kind of route parameter, such as that key. We can access the query parameters, which there may or may not be any. Or we can even take the request body, if this is a post request or a put request or something similar, and decode it into an interface or, say, a standard Go structure that you create yourself. Once you have this information, you can go ahead and return the information to your pleasing. So, for example, you can set the header information. You can define whether or not you want to write out a string to the client as a result, or maybe you want to take an interface that you define, encode it as JSON, and return that as a response. So you have options. A more realistic look at what we might be building is, take for example, we'd create this new router. We'd create a route. In this case, this is the root route, in which case we'd call the root function that we define, and we're only printing out hello world. Now the next step is, well, because we're going to be using Couchbase, which is a NoSQL database, we want to give kind of a background on what Couchbase is, in case you're unfamiliar. So Couchbase is a complete database solution. You have an embeddable database, you have synchronization support, and then you have a database server. So when it comes to the embeddable database is actually called Couchbase Lite, and it's primarily used for Android and iOS. So this is a database that gets embedded in your mobile application, so that way you can use NoSQL on the go. But it's not limited to just mobile. You can actually build desktop applications with it as well. So it's supported for Java. You can also use Objective-C as well. When it comes to Sync Gateway is actually a middleware. So what it does primarily is it synchronizes your data from the embeddable Couchbase Lite database to the Couchbase database server. So that handles synchronization to and from the mobile device. It also handles any kind of authentication and authorization. So you can define user roles and figure out what users should receive what data. It also handles conflict resolution. So if there's some kind of conflict, maybe you have two devices trying to write to the same data, you'll get notified and you'll be able to apply your own business logic based on what happens. Finally, we have Couchbase Server, which is going to be the focus of this presentation. Couchbase Server is a distributed database, so it's actually very easy to scale to thousands of nodes because it's a peer-to-peer architecture. Every node in a cluster is aware of every other node, and through the SDK, you'll have what's called a cluster map, so you'll be familiar where all the data resides on that cluster. It's a JSON document type database, so you'll be storing JSON data, very complex data or not complex data, but flexible nonetheless. And then there's a variety of SDKs that you can use as well to make your development life a little easier. So for example, we're going to be focusing on Go for this example, but there are others as well. So I also do a lot of Node.js and Java as well. When it comes to modeling your data, this is just a quick overview on data modeling. It's definitely not the focus of this presentation, but let's say that you have a relational database on the left. You have 3 different tables, and in a common scenario, you're always going to query those 3 tables through some kind of join. You're going to do some kind of complicated SQL query. If this is always the case, it may make more sense to use a NoSQL database and store all of those the data that you would have received in the join in a single document. So that way you can make one request, it's very fast, and everything is very organized. So when it comes to NoSQL, the denormalized approach is definitely an acceptable approach. If you don't want to store everything in a single document, and oftentimes it won't make sense to, you can actually store your data in several documents. You can even store data in say, a user's document, a user skills, user experience, and then establish some kind of relationship and apply that relationship in your application layer. So you do have options when it comes to this. So the next step is we want to install and configure Couchbase. So this is, if you've never experienced Couchbase, it's really to show you how easy it is to get up and running with Couchbase. So the first step is you would visit couchbase.com/downloads, and there's other ways which I'll mention as well. But the easiest way would, in my opinion, is to go to the downloads page. From the downloads page, you would select what version you want, whether or not you're downloading a mobile product or a server product. In our case, it's server, and then you would decide whether or not you want to download the Enterprise Edition or the Community Edition, and then the platform that you wish to install it on. The other options are you can use Docker, something that I use quite frequently, or you can use one of the cloud-hosted services like AWS or Microsoft Azure. And there's other ways that you can obtain Couchbase as well. Maybe you're using Ubuntu or some kind of Debian product. You could use apt-get. Maybe you're using Red Hat. You can use Yum. You can use whatever makes sense to you. It's very easy to get a hold of Couchbase Server. So after you do download it and you click that install button, what you have to do next is you have to configure Couchbase. So this is what we're going to do now. So I'm going to exit out of my slides here, and I'm going to navigate over to my web browser. Inside my web browser, all I have is an installed instance. I've gone ahead and I've installed it. I've done no further configuration other than dragging this into my install folder. What we want to do is we want to set up a new cluster. So we would say set up new cluster, and we would give it a cluster name. In my case, I'm just going to call it NRaboy. For your cluster name, it might make sense to say, you know what, if this cluster is in New York City, maybe call it NYC cluster. So that way you can better organize your clusters. The admin username and password, think of this as the root user to your database. So definitely make it as secure as possible. And then click next. On the next screen, you have the license to accept. Just go ahead and accept it after you've read through it. And then you can choose whether or not you want to finish with the defaults or you want to configure your disk memory and services. We're going to go ahead and configure those disk memory and services. So in this screen, you have the opportunity to define where your data is stored on the disk, where your indexes are stored on the disk, and RAM allocations for each of the possible Couchbase services. So for example, these are RAM allocations. These are not disk allocations. So even though if you chose a lower number or maybe even 6 gigabytes worth of RAM for data, you potentially have a lot more storage space for your documents after the fact, because it is not just an in-memory database. It is a persistent disk database as well. So I'm going to go ahead and allocate, let's say, 2 gigabytes of data service. I'll go ahead and leave the index service. I'm going to shut off the search service. We will not be using full text search for this example, but we will be using query, which also uses indexing. In terms of index storage settings, you can use the standard global secondary indexes, which are stored on disk, or you can use the memory optimized versions of those, which are actually stored in memory. So depending on your application needs, definitely choose whatever makes the most sense to you. And I'm not going to enable auto updates. So I'm going to hit save and finish. Just like that, in just a few wizard steps, we're brought to this Couchbase admin panel. And I didn't mention it before, but this is actually all, including the setup wizard, is actually a web application. So when you install Couchbase, you navigate to wherever it's hosted, and that'll be on port 8091. So I am brought into Couchbase. I'm going to skip over a few things, but I'll give you a quick run through on what you can expect in Couchbase Server. So first of all, you have the dashboard. You have a quick overview on what's going on in your cluster. If you wanted to, you click Servers, in which case you can see your server. You can see what kind of CPU load it's experiencing, the services that are enabled. If you had more than one server in this cluster, you would see the information about those servers as well. You also have the opportunity to add servers as well. Although there are other options when it comes to adding servers. You could do that through the CLI or even REST. So you don't have to use the dashboard to do all of that. For buckets, buckets are a collection of NoSQL documents. If you're coming from a relational database world, I like to think of them as databases. So if you're working with MySQL, you usually have a MySQL instance. And inside of that MySQL instance, you might have several databases. Think of it the same way as Couchbase. You have one Couchbase instance or cluster, and you have multiple buckets or databases inside of that cluster. So let's go ahead and create a bucket. And we're going to give it a name. So in this case, I'm going to name my bucket Demo. And I'm going to give it a RAM allocation of the total amount of RAM that I defined in the wizard. So I'm going to go ahead and give it 128 megabytes. You have 3 different types of buckets that you can choose from. You can choose the default, which is Couchbase. So Couchbase buckets are memory and disk buckets. You can choose an ephemeral bucket, which is an only memory bucket. And then you can choose a memcached bucket, which is more for key value operations and caching type things. So let's go ahead and stick with Couchbase. Add bucket. It'll take just a second to spin up. It's already available to us. We can view any kind of statistic information about this bucket. There are quite a few different graphs. You could also view graphing information about your servers as well. But you have every option when it comes to figuring out what's going on with your buckets and clusters. I'm going to skip over indexes and I'm going to skip over query because we'll be seeing those as we progress through this presentation. But the search, which I've decided not to enable, is if we wanted to use full text search in our application. But for this application, we're not going to be using full text search. If we wanted to, we could use what's called cross data center replication. So if we have multiple clusters, we could replicate our data between those clusters. And note that this is a little different than nodes in a cluster, because if you have 10 nodes in a cluster, you can replicate data between those nodes. Cross data center replication is cross cluster replication. Now that we have a bucket called demo, we probably do want to add a user. So this could be an application user or something else, something that will allow us to interact with Couchbase in some fashion. And then in this fashion, it's going to be just accessing our bucket through the application layer. So we'll say add user. I'm going to give it a username. I'm going to call this one demo as well. Doesn't need to be called demo. And I'm going to give it a password. And after I have the username and password, I'm going to define what roles this user has. So for this particular application, I'm going to say that we're going to have data roles. So we're going to allow this user to be able to read data from key values on the demo bucket. We're also going to allow this user to write data based on keys, also on the demo bucket. But we're also going to allow querying capabilities. So this is something a little beyond key value operations. So I'm going to say that we're going to allow query select on demo. Now you'll notice I didn't choose all with the asterisk because you know what, it's a little unsafe if this is just an application user to give it access to multiple buckets, whether that be present or future. So definitely be cautious when it comes to creating your user accounts and only give them the amount of privilege that they absolutely need. I'm going to hit save. All right, the user has been added to our Couchbase instance. So what we're going to do now is we're going to jump back into the slides, and we'll be progressing back and forth throughout this presentation between the database and our code. So let's jump ahead here. I'm going to hit play. So now we're going to focus on using the Couchbase Go SDK with our Couchbase instance. So when it comes to using our database, we need to first download the Go SDK. So there's 2 different versions that we can get. We can get the stable release, which is definitely recommended for production, or we can use the developer release if we're feeling a little adventurous. And both of those can be obtained with Go Get. Now, once we have downloaded our SDK, we need to establish a connection to the database in our Go code. And you'll notice that I have a global variable for bucket. You don't need to do it this way, but I'm doing it this way so that way all of our endpoints for our web application can access this same bucket instance. Then inside of our main function, I'm doing connect. I am connecting to a particular cluster or a particular node in a cluster. In this case, it says localhost on the slide, but I do have it somewhere on my network, so I'm using an IP in reality. If I wanted to, I could provide multiple nodes in the connection string. So for example, maybe this first node isn't available, it's offline. It'll try to connect to the next one. But it only ever needs to connect to one successfully because, again, it is a peer-to-peer database. So once you're connected, you'll have knowledge of every other node in that cluster. We'll authenticate with the username and password that we had created for our application, and then we'll try to open up a particular bucket, which we had decided was called demo. Once we do that, we can start listening. And as of right now, there are no endpoints. So what I want to do is I want to show a quick demo, and then I'll show you the code behind that demo. And like I said, we're going to be bouncing back and forth. So let me exit out of my slides here, and let me open up Postman. So we're going to be using Postman to issue all of our requests. So the first thing, so this to give you some context here, this application that we're building is around customer data. Well, not necessarily customer data, but shopping data. So we're going to have customer information, we're going to have product information, and we're going to have receipt information. So as of right now, our bucket is empty. We have no customers in our database. So it makes sense to create a customer. So we're going to say well, actually what I want to do is I probably want to run this application first. I'm going to say go run. I'm going to run my Go file. It should be running now. I'm going to say HTTP localhost. I'm actually running this on port 12345, and I'm saying this is a customer endpoint. And this endpoint expects a post body in JSON format, and it's expecting a first name, which I'll use as my name, and a last name. So very simple. And I'm going to send it. If it was successful, it should have returned an ID. So this is the ID of the document that was saved. So let's go ahead and swing over to our Couchbase dashboard, and we go to buckets, and we go to demo documents. As you can see, our document that we had just created has been saved. So Nick Raboy was given a type of customer, and you can see that our document key was also saved to the database. So let's go ahead and try to do another insert. Let's go back to Postman. This time around, we're going to insert a product. So the product information is a little different. Let's go ahead and say we want to save, what's this product's name? Let's say Nintendo Switch. And the price on that is $299. We'll hit send. You can see that an ID was returned again. So if I go back into my Couchbase dashboard and I go to view my documents, I now have two documents that reside in the same bucket. So when it comes to documents, you can have as many different types of documents as you want in a single bucket. Think of one bucket as an application database, like I said. You can expand them across several buckets if you want, but good practice would be to store everything in the same bucket. So I do have two in this case. The next step is maybe I want to query for a particular customer. So let's go ahead and copy that ID. Let's go ahead and go back to Postman. I'm going to change this to a GET request. I'm going to change the path to customer, and I'm going to paste in that ID and hit send. As you can see, it returned to me the customer information, which includes the type as well as the ID. So everything up until now is expected. So let's go back to the slides and figure out what just happened. So So the first thing I said was I said that we're focusing on customer information, product information, and receipt, even though that as of right now, I've only shown you the customer part and the product part. We have 4 Go structs here. The credit card information is actually inside of the customer, even though that we didn't provide any yet. Product is pretty flat. And then receipt is going to represent a snapshot of our data. So for example, let's say that a customer has placed an order for product. Well, we all know that products can go on sale sometimes. So it doesn't necessarily make sense to have some kind of relationship between product and customer inside of a receipt. Instead, it makes sense to snapshot that information so the receipt accurately reflects the information at the time of purchase. And there's other ways that you can do this, but this is one way that might make sense. I showed you this already, but this is what our data may look like inside of our database. So for example, customer, I didn't show you it with credit cards previously. In fact, credit cards wasn't even a property for my customer document at the time. And that's normal because we didn't provide it. The product information, we might have a product that represents what we've saved. Now, as far as what we did when we said create customer, so we did a post request against this customer endpoint, which is actually calling the create customer endpoint. We're saying that our response is going to be of type application JSON, and we're taking that post body and we're decoding it into a customer object or a customer struct. And remember that customer struct, the product struct, receipt, they all have JSON annotations as well, which map to what we're storing it in the database. Once we've decoded that request body, we're assigning the type to be customer because if we didn't add a type property, and we don't have to, but if we didn't, it'd be very difficult to determine what type of document it is that you're working with. So it's good practice to have a type. We're also defining a new unique ID, a UUID. It does not have to be a unique document key for your documents. Instead, you could use something like an email address if you wanted to. It could be some kind of incrementing number. It's totally up to you. But when we call bucket.insert, we're passing that ID, we're passing the customer object, and we're also passing in an expiration time. If we say expiration of 0, it means the document does not expire. If we pass in a positive integer value, it means that the document will expire after that amount of time. And by expire, I mean the database will automatically remove that document without any kind of human or application intervention. You might be wondering, well, why would an expiration be useful? Maybe, for example, think sessions. Maybe you want to log your user out after 60 minutes. So you put 60 minutes in there. It's actually going to be seconds, but you put 60 minutes worth. And then after 60 minutes, that document will delete, and then maybe your application will not be able to find that document and prompt that user to log in again. But that's beyond the subject of this particular presentation. Now let's say that the insert failed. So maybe the document ID already existed in the database. In our case, because it's unique, that should never happen. But you know what? Maybe it does. So we'll return an error. If there was no error, we're going to return the ID back to the user. So likewise, the same kind of thing happens for inserting new products. So there's going to be a lot of repetition in this presentation, but that's a good thing because it shows you that you don't need to jump through too many hoops to get the job done with Go and Couchbase. So in this case, instead of working with a customer document, we're working with a product object, and we're also setting the type of that object to product, and we're following the same steps that we did previously. Now, if we wanted to get a particular customer, so now we're not creating data, we're getting data. We're hitting this endpoint, this customer endpoint, and then there's a route parameter called ID. We're following the same steps. We're saying that we want to return JSON data, but this time we're using mux.vars to extract the route parameters. We're using the route param, the ID, so that key that was up there, and we're saying customer.id equals that. And we're also using that value to do a bucket.get. So when we do bucket.get, we're taking that ID and we're storing the data that was retrieved in a new customer object. If for some reason there was an error, maybe the document key does not exist that we're trying to use, then return an error. Otherwise, what we're going to do is we're going to return the actual customer data, which is exactly what we saw. So now there's another thing that we can actually do. So let me exit out of my slides here, and I'm going to open up Postman. Let's say that we want to update our documents. So we're going to do a put request, and let's say that we want to add credit card information to a user. This is pretty common, right? You're inside of your web portal, and you have your profile up, and then you have a screen that says, you know what, add a credit card to have on file. Where I'm going with this is, what happens if your document is very large? You don't want to have to send that document over the network multiple times. So what we're going to do is we're actually going to edit part of a document without ever touching the full document itself. So the endpoint should be customer. Actually, we can save that. Let's figure out what that endpoint is. I actually forgot off the top of my head. So it's customer, and it's credit card, and then ID. So let's try that. Customer / credit card, and then /ID. So this is our customer. We're going to go to our body here, and we're going to add credit card information. So the first information would be the brand. Let's say that this is Visa. Let's say that our number is, it doesn't matter, just some random numbers here. Actually make it a string. And then the expiration. So I'm going to hit save, and in theory it should work. So it returned the credit card information that I had just added. So if I go back into the Couchbase dashboard, and I go to Documents, and I click on the customer document, which is mine, it now has a credit card array, and it has that one credit card that I added. So it embedded that information in the document. Now, if I wanted to, I could easily take this information, lines 6 through 10. I could create a new document for this credit card, and inside of this array, maybe have an ID that I reference. That's acceptable as well. But you know what? For this particular example, it kind of makes sense just to store the credit card information for a user with the user. So that way our requests are simple. Now let's go back into our Postman tool. We're going to say we want to get the credit card information for a particular user. So the endpoint should be the same. I'm getting the credit card information for this particular ID, and I'm going to hit send. And it returned that information for me. It returned an array because there's the potential of having more than one credit card, but it did not return the entire document. So let's figure out what exactly we did here in the slides. So in this example, remember I said, you know what, maybe we've got a potentially large document. Maybe we don't want to have our network latency suffer. So this time around, we hit this endpoint, customer credit card with a route parameter. We're setting the response type, and we're getting that ID from the route parameters. What we're doing now is we're actually doing what's called a sub-document operation with Couchbase. So we're doing a mutate in. And by doing that, we can actually provide the ID of the document that we wish to alter, and we're providing a path within that document that we wish to alter. So we're saying that we want to edit the credit card's property within that particular document. Now, if that credit card's property does not exist, we added a true there, which means that we're going to create that property. So remember, it didn't exist previously. And what we're doing is we're saying we're going to add this credit card object, which was passed in with our request, to this array. And then we're returning the credit card information. We could really return whatever we want, but we're returning the credit card information. If we wanted to chain together several mutations, so maybe you've got a very large, very complex document, you can chain together several mutations without ever first obtaining that document, which is good if you've got large documents, or if network latency is a big issue for you. Now let's say you wanted to get that document. So in this case, we're saying this is the same endpoint, except for instead of put, it's a get. We're saying we want to get that ID from the route parameters. And instead of mutate in, we're saying lookup in. So with the lookup in, we can provide the ID for that document that we want to look up in, and we're saying we want the data that's in the credit card's path, so the property. If there was an error, return it. Otherwise, let's get the fragment that we tried to look up. And just like with the mutate in, you can chain together different lookup in operations. So if you wanted to get maybe the first name in the credit cards, you absolutely could. So in this case, the only fragment that we returned was credit cards. So we're going to return that in the response. Now, up until now, everything that we've done was ID based. So this was all key value operations. Hence, in our user role was the data reader and data writer. So now what we want to do is we want to focus on actually querying that data based on other properties other than the ID. So Nickel is Couchbase's own implementation of SQL. So it's a non-first normal form query language. It's SQL-like. So if you're familiar with MySQL, SQL Server, Oracle, you can get by just fine using Nickel in Couchbase. The difference between Nickel and SQL is that Nickel extends SQL to do other things. So for example, if you have nested data in your JSON documents, you can work with that data. If you have a very flexible non-uniform schema amongst all of your documents in a particular bucket, it works fine. If your data is distributed across a cluster, which is not necessarily the norm when it comes to relational databases, you can still query for that data with Nickel. So Nickel is expressive, so you can query every part of those JSON documents. You can use aggregation on arrays, you can do subqueries, you can do a lot of cool stuff. Like I said, it's very familiar if you're coming from a SQL background. So you have select, you can select properties from documents, you can use the asterisk as a kind of wildcard, you can do inserts and updates in case you didn't want to do bucket.insert, or maybe you didn't want to do a mutate in. You have everything that you would come to expect in SQL. But it's feature rich beyond just SQL, like I had mentioned. So again, you have access to every part of that JSON document, something that you wouldn't normally see in a flat relational database. You have the opportunity to still do joins between your documents. Some things that might be unfamiliar to you, maybe a nest and an unnest. So maybe you have a document that has an array in it. Maybe in your result set, you want flat results. You don't want to have to deal with results that have arrays. So you can use unnest, and that will flatten your results. Or if you wanted to go the other direction, you could use nest. You can work with prepared statements, covering indexes. You can work with a lot of cool stuff. So an example of a query that you can do in Couchbase. So in this case, we're selecting several different properties from a particular bucket, and we're saying that we want to unnest one of those properties and join it against another set of documents. We have the where operators, group bys, having bys, having and then order bys. We have all the stuff that you would come to expect. And the great thing about this is inside of your application, you can write this query and the database will take care of the rest. If you didn't have this opportunity, maybe you're using another NoSQL database, you might have to write a lot of application code to accomplish the same thing. With Couchbase, you just write your query, offload it to the database, and get the results in the format that you wanted. So the next step here is we need to actually create indexes, so that way we can do our queries. So we're going to bounce. Actually, before we do that, let's jump back into the slides here. When it comes to actually running your queries, and we will create indexes in just a second. When it comes to running your queries, you have opportunities. So you can use the Couchbase dashboard. You can use the command line tool. You can use REST. You can use there's plenty of options. The SDK. Depending on what you're using, you can find the query workbench through the admin panel or the CLI at any of the paths for your operating system. So now let's focus on actually creating an index, so that way we can run our queries. And we're going to sample our queries in the dashboard before we sample them in our Go application. So going back into the dashboard, I go to indexes. You can see there are no indexes yet. So instead I'll go to query, and we'll create one index. So we're going to say create primary index on, and then our bucket name. So our bucket name is demo. So I'm going to execute it. And now we have one index in the indexes section. So now we can actually write our queries. So let's say inside of our query workbench, we're going to say select star from demo. So what this did is it returned all of our results, regardless of what type they were. So for example, I have user information, I have product information. Let's say we want to narrow this down, and let's say we want to clean up our results a little bit. So instead, we can say demo, and we can also say where type equals, let's say user, or we'll say product. Execute. Now we have just the product information. There's no demo prefix behind it. And it's great like that. Now, you saw previously that I created a primary index. So primary indexes are great for prototyping. You should never use a primary index in production. It will be slow because you're trying to cover all properties in all of your documents. So what you want to do is you want to create a specialized index. So first of all, let's say, let's do an explain. So this is a query plan if you're familiar with it in a relational database, but I'll execute it. And you'll see it has information about our actual query. And you'll also see that we're using the primary index. So let's go ahead and create a more specialized index. So we're going to say create index, and we'll call it, let's call it by type on demo. And we're going to define what properties we want to index. So we're going to say the type property. I'm going to execute it. It created it. Let's go ahead and run that query that I had ran previously. Execute. This time around, it's using my by type index. It's picked it up. So if I wanted to remove something, like if I wanted to remove the primary index, I would only be able to run queries that meet the by type index criteria. And like I said, you could use the primary index for prototyping. It's perfectly fine. But definitely create custom indexes for production. But we'll leave it as is for now. Let's go back into our demo here. What I'm actually going to do is I'm going to run a query in Postman. This time around, I want to say get all customers, and we're going to look at the code behind this in a second. I'm going to say send, and it returned all customer information, which in this case was just one particular customer. Now, what I do want to do is I want to create another product. It'll be more useful for what comes next in the demo. So let's go ahead and create a new product. We'll add a body. For the name, we're going to say name, let's say Dark Souls Remastered, which is a video game, which will be for the Nintendo Switch. We're going to give it a price, and this one will be $39.99. And I'm going to hit send. It worked as expected, and now we can actually focus more on what comes in our slides. So when it comes to getting our customers, we actually use a nickel query in our Go code. So we hit this endpoint called /customers, plural, because we're expecting more than one. We're saying that we're preparing a slice of customers, and we're saying select meta ID as well as all properties from a particular bucket, and we're going to say where that type property equals customer. Now you'll remember that we're not actually storing the ID in the document itself, so that's why we're actually trying to get the ID from the meta information. Now if you wanted to, you could store the ID in the document itself. That's perfectly fine. But it's also perfectly fine to get it out of the meta as well. When we say execute nickel query, we're passing in that query. The next parameter is nil because that's actually our parameterized query parameters. So if we wanted to take user data, which we will in one of the coming up slides, we could add parameters to this query for protection against SQL injection. If there was an error, maybe your query was malformed, return the error. Otherwise, we're going to take that result set, we're going to loop through each of the results, and we're going to append them to that customer slice. And then we're going to encode that customer slice and return it back to the client. Likewise, if we wanted to get all of our products, we would do a very similar query here. The only exception here is instead of type equal customer, we're saying type equals product. Let's say we wanted to do something more complex because we have another data type that we've yet to use. So let's say we want to store a receipt. We want a customer to purchase some things and have some kind of order receipt. So this time around, we're going to say post, and we're going to say order, and we're going to provide order information. And I'll explain what happens after this. So we're going to say customer. For the customer ID, we're going to look up in our database. So we're going to go to buckets. We're going to look at our documents. We're going to get this customer ID. We're going to include that in Postman. That's actually a string. For products, that's going to be an array. And that's actually going to be an array of objects. So ID, so the first item that we want to purchase, let's go ahead and look at it. We're going to purchase both that Nintendo Switch and that Dark Souls video game. So I'm going to copy that ID over. And in reality, you wouldn't be typing this in manually. Your front-end application layer would probably get this information and post it through some kind of AJAX call. Let's go ahead and get another ID here. And let's get that video game here. And we'll save it, we'll send it. And we got an ID back. So if we go into our database, we should have one new document here representing our receipt information. And you'll see that it now has information about the customer, as well as the two products and a total that we paid. And remember, we're snapshotting this because, as everyone knows, product information is subject to change. Even customer information is subject to change. So say, for example, maybe I had more information in my customer. Maybe I had an address that this was mailed to. We don't necessarily want that to change as time progresses. So this is a snapshot receipt of a product that was ordered. So let's go ahead and look at the code behind this. So we'll go back into the slides. So this is long and crazy here. What's actually happening is I'm taking that customer information that was passed in a post body. I'm taking that product information, and I am extracting the IDs for each. Then what I'm doing is I'm running a NiQL query. This NiQL query is actually using subqueries. So two subqueries, one for each of what we want to accomplish. So the first subquery is we're saying that we want to get the customer information based on the ID that was passed. So you'll notice in the middle there it says as customer use keys $2. So the $2 is going to be a parameter which represents our customer ID. The second subquery in here is we're actually getting the products. So we have two products, so it's an array of IDs, and we're saying use keys $2. So we're getting both product informations. And then finally, we're saying use keys $1 as well. And essentially what we're doing is we're just getting all of that information so that way we can store it in a new document. So that way we don't have to run this potentially expensive query numerous times to get what we need. But there's actually a catch here. So because I'm using use keys, we're not actually using an index in this case. So this is actually a CRUD operation using NiQL. So it'll have blazing fast performance. But let's say, for example, maybe you're not using use keys and you're actually using indexes. That's where it might become valuable to do a snapshot like I'm doing now. So basically what's happening is after I get that data, we're looping through the results and we're massaging it into a format that we want, which is the format of a receipt. So very interesting stuff. Now let's say we wanted to get a receipt, and I know I didn't show this demo, but what we would do is in this case, we would take the ID for a particular customer because we want to get all of that customer's orders. And we would create this nickel query. We're getting the ID, we're getting all of the properties, and we're saying where the type is equal to receipt, and then we're saying where the customer ID is equal to whatever that ID was passed, the parameter. And you'll notice that receipts.customer.id is a nested command here. It's not flat, so nickel is very powerful in what it lets you do. After you run this query, you loop through the results, and you add the results to a receipt slice, and you encode that as JSON and return it back to the client. Now, if you wanted this example, it is on GitHub, all the code that I used, so it's freely accessible. You can go ahead and run it yourself as long as you have a Couchbase instance set up, and as long as you have the code inside of your project point to that instance. And mine's running locally on my network. It could have easily been on my local machine as well. If you wanted to learn more about Couchbase, the Go SDK, you could also visit the Couchbase Go SDK documentation. Now, here's some more Go ideas. So I just showed you a web application example, but it is definitely not the only thing that you can do with Go and Couchbase. For example, I actually worked on a project, so I needed to take my MongoDB data, which is also a JSON document database, and I needed to import it into Couchbase. So with MongoDB, you can actually do a dump, and it'll dump all of your documents into a file, line by line. And in that file, what we want to do is we want to loop through each of the lines, and we want to do some kind of insert operation into our new database. And with Go, it's actually very easy, very convenient to do that because of what Go offers. So for example, what I did here was I created what's called a Go routine. So these are worker threads in a sense. I created several of them, and their job is to take the data that was read from the text file and simultaneously insert it into Couchbase. So I read the data from the text file line by line, and these worker threads start doing their work. Now, what this looks like is, so for each worker, it reads from that data channel, which was the data from the text file, and it calls the CB import function that I made. And this is a lot more simplistic to what I really did that's in the GitHub project. But essentially what you're doing is the worker is going to look at that line. It's going to do some kind of manipulation to massage it into a format that you want for Couchbase, and then it's going to call bucket insert. And like I said, it does all of this in parallel with X number of Go routines that you've started. So very interesting stuff. You don't have to do strictly web applications. You don't have to do strictly scripting. You have a lot of opportunities. Now, if you need help with anything, so what you can do is you can visit the Couchbase developer portal to learn more about using the Go SDK with Couchbase. There's some nice documentation. There's a lot of tutorials that I've written on the Couchbase blog. And then there's a lot of good help in the forums from, say, the SDK engineers, as well as myself. If you want to reach out to me directly on Twitter. I'm very responsive, and I'd be happy to help you with any of your Go needs.